The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and welcome to the Ethics webinar. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have. Looking at the handout section of the GoToWebinar panel, please note also that a PDF copy of today's presentation is available for reference. With that, we will go ahead and turn things over to Tom Panet. Hello.
Good afternoon, Mike. Thank you very much. Thanks for the introduction, and thanks to the folks at LTAP for picking me to do this presentation. This is the, I think, third year in a row that I've done the presentation through LTAP, and those of you who have attended my ethics seminars in the past recognize, and I express this, that I take some time to try to think about different avenues to present ethics, try to come up with something new, and it just kind of dawned on me late last year that there's a lot of groups out there that purport to talk about ethics, have them in their codes and creeds, not only in the United States, but all across the globe. And I thought, well, what wouldn't be interesting to see what they talk about, maybe how they're different than what we're used to, whether it's the Ohio Revised Code, Ohio Administrative Code, ACEC, ASCE, NSPE codes, or the engineer stuff that maybe we're commonly used to. And see what's going on in the rest of the world and see how they maybe differ. And then also analyze, if we can, briefly, because we don't have so much time together, what if they do have engineering failures, how those failures correspond to their different codes. And that's sort of the impetus for this presentation, Engineering Ethics Here Around the World. As Mike said, my name is Tom Panet. I'm a professional engineer and a lawyer. I work for the law firm of Kegler, Brown, Hill & Ritter here in Columbus, Ohio. I've been here for 3 years, recently promoted to partner. I retired from ODOT after about 32 years in government. And part of my law practice now I represent professional engineers in front of the Professional Engineers and Surveyors Board, as well as other professionals in challenges to their licensing. So not only do I, talk the talk, I also, as part of my practice, help folks walk through the challenges that they deal with and ethical issues. So let's go ahead and get started. I did the research on this project. I found that there are more than 50 groups across the US and the UK that talk about, engineering advocacy, engineering the groups, societies, and Canada has 22 of their own and 30 others across the globe. So there was actually an overwhelming amount of information that I was starting to distill and get through to put this presentation together. And all of them talk about similar ethics issues, but many of them have nuanced differences, and we'll talk through those when we get to that time. But what I also like to do with my presentations is give the audience a summary of what we're going to be talking about today. So here is that. We're going to go through these engineering societies in the United States, some of the ethics standards with them and these societies around the globe. Talk a little bit about the differences between those standards. There are many groups that put out top 10, top 5, top 100, engineering disasters in history or whatever. I found top 25 engineering disasters that picked out on my research. We're not going to go through by any means all 25 of them. That would take days. But we'll hit a couple in the United States, and then we'll hit a couple in some of the other countries. Then again, we'll talk about how their codes of ethics may have been violated and where the engineers fell down, and again, maybe a little bit of differences. Gallup puts out the surveys every year regarding professionalism and trust in professions, and they did one recently post-pandemic, and there's some really interesting results that I want to share with you, and it even applies to engineers. We're going to talk about real quick the engineers, the PEPS board's ethics requirements and the regulations, and what I'd like to do with that is sort of look back and what we have discussed earlier in the presentation and see how our rules sort of are similar or different than other rules across the world. And then ODOT recently came up with an update to their conflicts of interests policy. I want to share that with you. I'm sure most of you, not all of you, know about it. Give you my sort of quick take on it. And then final thoughts and questions. I have a lot of slides. To be honest, I didn't do a great job of culling these down because there's so much information that I can share. And I give that to you folks. You know, like Mike was saying, you can take the copy of this presentation and download the PDF and see all the stuff I talk about. Just so you can, if you want to follow up for your own curiosity. But I anticipate this will be together for an hour, and I'll stick around for as long as it takes to answer any questions after that. Happy to do it. And then, you know, most of you know my contact information. I'm out there on the web. If you have any follow-up questions, I'm happy to answer those. So let's go ahead and get started. So these are the engineering societies that I found in the United States. This is not an exhaustive list, but it's an interesting list. I'll start with just the first group that's interesting, Alpha Omega Epsilon. That's actually a sorority. And then I thought, well, of course, you know, there are colleges across the country, and they all have, you know, lots of them have degrees you get in engineering, and lots of them have Greek life. And of course, there's going to be all these fraternities and sororities. So that's kind of where you start if you want to join these groups, or you start to sort of get into this thought process of participating in not only the profession of engineer, but the social aspects and the networking and the other things that come along with being part of these groups. These all kind of start in college. At least if you want to take the opportunity to do it, you can do it. And not only are they there for the students, and most of these, the ones that like Alpha, Omega, Epsilon, are run by students, but they're also run by, you know, former students, and you can continue that networking through a lot of these. So it was interesting to me to see, well, right off the bat, this opportunity for societies starts right when we start getting our education. Well, and then the first question then I had, well, what do they do? And so when I picked out a handful of these groups, and I'll get to those in a minute, I read their social media, I read their bylaws, I read their constitutions, I read what do they say that they're, you know, promoting out there. And a lot of them are very similar. They all want to network. They all want to share, even in the college level, best practices with engineering. And they're important. They're important for us as engineers because we can't do this alone, right? No man's an island, no woman's an island. They're important for us to be involved with, whether at college level or now that we're, you know, graduated and we're professionals. It's important for us to stay involved with these groups. Again, to do the networking, but also to understand what's going on with best practices, to understand new developments in our industry. That makes us better engineers, and that actually makes us more ethical engineers when we not only participate, but when we share our ideals, and when we mentor other folks. So it's important to, these groups in and of themselves, in my mind, are ethical and allow us to, you know, promote these opportunities for advancement, to go to conferences, to share knowledge, and you know, to educate not only ourselves, but also to share this, what we know, with the public. These publications that like NSBE puts out or ASCE puts out, those available to the public so they can see what we're doing, what we're talking about, and what we're thinking about, and what we're dealing with in challenges. You know, lots of times in these articles and these magazines, they talk about engineering failures. They talk about people who may have slipped up. And so it's good for us to be exposed to that and to be humble, and for the public to understand that we can recognize our own failures and then always try to do better and improve on them. So here are the handful of groups I found that in, you know, college engineering societies. And this is what they promote. So for instance, Alpha Omega Epsilon is a sorority. It's actually an international sorority, and they're committed to providing, they say, friendship, leadership, and professionalism. And part of these groups too, again, when I read their, you know, social media, they're kids in college. They're having a good time. They're, you know, they want to have friendships. They want to have fun. Alpha Phi Mu, for instance, fraternities, their goal is to promote networking and to have fun. You know, good. They should be having a good time. It's the time in college to have fun. But some of these groups are actually fairly serious, more serious than others. So Chi Epsilon is an honor society, and they've been around since 1922. They have 143 chapters and 120,000 members. They have a constitution, they have bylaws, and they're there to, you know, recognize outstanding students. Tau Beta Pi, also an engineering society. They claim to represent the entire engineering profession, founded in Lehigh University. So a lot of these, as you imagine, these different groups, societies are started somewhere. They started in a university or another, and then they spread from there. So this one started in Lehigh. It's been around since 1885, and I thought that was kind of sort of fascinating. Theta Tau actually publishes a magazine. They call it The Gear, and they claim to be there to develop and maintain high standards of professional interest among its members, unite them to a strong bond of internal fraternal fellowship, and develop engineers as leaders. Starting, as I said earlier, starting in the college level, getting involved with these type of serious fraternities and sororities, I think that allows folks to embrace that ideal early on and likely carry it on in the future. Phi Sigma Rho is an interesting one too. They actually say they want to, their sorority, and they say they want to re-engineer sorority life through balancing the demands of college with having fun. And that's also interesting too, right? Because, you know, our profession is demanding. To be successful as an engineer, you've got to spend a lot of time and effort doing it. It's nice, I think, that this group right off the bat says, look, you know, we know it's important to have a collegial atmosphere. We know it's important to study, but I also know that it's important to have a good work-life balance and carrying that through to success from an early stage. So these are just some of the, you know, fraternities and sororities I found in that overall list. These groups are actually more ethnically centric societies. So National Society of Black Engineers, Society of Hispanic Professional Engineers, and the Indian Council of Architects and Engineers. These groups not only talk about promoting engineering and networking and, you know, STEM issues, but also focus on their ethnically centric, you know, membership. So like the Indian Council for Architects and Engineers claims to only have 200 members, 200 American Indians that are either architects and engineers. Conversely, the National Society of Black Engineers has over 20,000 members, and they're considered an international organization with 790 chapters. They're run by students exclusively. Now they were interesting. Their social media was especially interesting for me because it talks a little bit about, you know, their, I guess, their group's interaction with society. And their Facebook says that they are engineered to withstand systematic racism and institutional oppression. And obviously that's something that I have not experienced that, but they have. And so in their groups, they're talking not only about being engineers and being professionals, but also trying to address the issues that their groups deal with in society. And I thought that was kind of fascinating. All three of these groups are started in the 70s. And in the Indian Council for Architects, 76, the National Society of Black Engineers, 75, and the Society of Hispanic Professional Engineers, 74. I don't know why that is, and I wonder why that is, if there wasn't more perhaps cultural awakening, cultural awareness in the 70s that may also have led to these groups getting more engaged. So those are the ones that you can join if you want to, that are not only talk about being professional engineers and focusing on opportunities for networking and STEM, but also talk about their different social and economic issues that their members deal with. These are the big fish: National Society of Professional Engineers, Society for Women Engineers, American Society of Civil Engineers. They're huge groups. They're international. They've been around for many, many decades. They have hundreds of thousands of members. They present. They have seminars that you can go to, magazines that they publish. And so to join these groups, you're really kind of getting yourself into a much more national perspective, an international perspective. I'm sure many of you, I've been a member over my career on and off of a couple of these groups. And I also am a member of the Order of the Engineer, but I found their literature kind of fascinating. They don't consider themselves to be a member organization. I don't know how else to describe them, but they said they're not a member organization. Their idea is, look, you can sign up to be a member with, I guess, on the Order of the Engineer. You can take the oath of the Order of the Engineer. You can get your ring, and I've done it. You know, here's my ring, and when I sign papers, occasionally it clicks, and I remember my obligation of an engineer. But they don't consider themselves to be a member organization. They've only been around since 1970. They, though, were patterned after the Canadian Order of the Engineer, and I'll get to them in a minute, but this is their obligation. So when I do my presentations, I ask folks to think about what I'm sharing with you, and we're going to read some of these specific, obligations and orders, and they're going to have phrases and terms in them that are relevant, and I think relevant especially to the concept of ethics and what our obligations are as engineers and ethical engineers. So as an obligation of an engineer, I committed because I signed this years ago, to pledge to practice integrity and fair dealing. Integrity is a term that we should be familiar with. It's in our Ohio Administrative Code. For tolerance and respect, to uphold devotion to the standards, the dignity of my profession, to always use my skill with the obligation to serve humanity, and making the best use of the earth's precious wealth. To engage in none but the honest enterprises and use our skill and knowledge to, without reservation, for the public good, and performance my duty and in fidelity, so complete commitment to my profession, I give my utmost. So this is the obligation of the engineer. The obligation of the engineer was modeled after Canada's Order of the Engineer. The Order of the Engineer is created back in May 1st, 1925. And the calling of the engineer, these paragraphs here that I'll get to in a minute, was actually drafted by Rudyard Kipling back then. Rudyard was asked by Canadian engineers to draft up this calling because they had a major failure. And I'll get to that. That's going to be one of the failures we're going to be talking about today. But this Order of the Engineer calling was set out to express I think some admonition and humility on the behalf of the engineering profession, recognizing that it was actually engineers' poor decision-making that caused this tragedy. It was actually the collapse of the St. Lawrence River Bridge in Quebec. And from that collapse, from those steel girders were made steel rings that were presented to 200 engineers during the first Order of the Calling on, like I said, May 1st, 1925. And they gave this oath at that time. And we'll go ahead and take a quick look at it because I want to, as we think about it, contrast that with the previous Order of the Engineer document we looked at. Now this is written kind of in Old English, quite frankly. Rudyard Kipling, famous poet. So he says, he drafted, I, Tom Pannett, in the presence of these other engineers, my better, and in my calling, so basically my solemn obligation to my profession, bind myself in my honor in the cold iron of the ring that they put in their pinky, that the best of their knowledge and power I will not henceforth suffer or pass or be privy to the passing of bad workmanship or faulty material in aught that concerns my works before mankind as an engineer or in my dealing with my own soul before my maker. I won't read the rest of it, but these paragraphs were actually again, drafted after the failure of the St. Lawrence River collapse, and the reasons it collapsed were because bad workmanship, faulty material, an engineer deciding that he didn't need any more help, he didn't need any more information, not responding to what was going on in the field. And I think they took the facts of that case, that situation, and developed this document to address a lot of those failings. So I thought that was sort of fascinating. So this is, the calling, ritual of the calling that if you're in Canada, I don't know if there are any folks from Canada in the audience, that you sign up for when you want to get that you're, professional engineer, be a member of this group as a professional engineer in Canada. So there are, as I said in the beginning, not only groups in colleges, groups nationally, but groups in societies that are international. Excuse me. Here's a list. This again is not an exhaustive list. So you can participate in the World Federation of Engineering Organizations, or the Society of Petroleum Engineers, or National Society of Black Engineers, and National Society of Geodetic Students organizations. These groups are international groups. So whatever your interest or your penchant or your flavor is, you can do that locally, nationally, or internationally. And I thought that was fascinating, but there's this many groups out there, and it makes sense. There's hundreds of thousands of engineers across the world, and there's lots of groups to be involved with, and you can choose to be involved with ones that are general or specific to your profession. Engineers Europe is a group that claims to represent engineers in 33 countries, has over 6 million professional engineers, they claim, in Europe. They were actually put together by a group of French and German engineers while they were rebuilding after World War II. They came together and recognized, look, we need to work as a cohesive group. Where there was so much damage, right? We all know in Europe because of all the bombings and all the wars over the years. They wanted to put their heads together, so they agreed and founded this group, Engineers Europe, to work collaboratively. And then they created, therefore, engineering competencies so they could create certificates for professional engineers. So this group actually evaluates people to become professional engineers with Engineers Europe. They have applications that are, peer review. They update their standards quite frequently, and they, just like NSPE or other groups, provide professional development and maintain their magazines and information and the database for continuing education throughout Europe. They have their own sort of creed, and their creed is similar. I'll contrast it with the National Society of Professional Engineers Code of Ethics in just a minute, but you can read that this is the creed for Engineers Europe. So they shall maintain their competencies, right? They agree that they need to stay educated at the level to undertake the tasks that they're going to perform. They won't misrepresent their education, qualification, professional titles. You should be familiar with that. That also was found in the Ohio Administrative Code. Provide partial analysis, carry out their tasks to avoid danger, accept appropriate responsibility for their work, and carry it out under their supervision. And obviously it goes on, and basically in the last one, challenge unethical behavior when observed or experienced. So they are similar. I mean, you can see these different commitments, their codes of conduct are not dissimilar. And that's the reason for that, we'll get to that in a minute, is because historically, Western ethics, Western engineering ethics started in one place, all started in England. And from that, developed these codes of conduct, not only for the United States and for Canada, but England, but also for Europe. So that's sort of interesting. So there are some similarities here, right off the bat that you can see. Excuse me. The National Society of Professional Engineers Code of Ethics says we shall paramount the safety, health, and welfare of the public. And then obviously, similarly, the Code of Conduct for Engineers Europe said we should act with integrity and in the public interest. So we could go through each one of these points and paragraphs and recognize that they are, in essence, the same things, but just worded a little bit differently. What I found somewhat interesting, though, and this would be not only in Europe and Canada, but also in Japan, is that accepting responsibility for your work. I think that we say that in our code in the United States, but I don't think it's quite as explicit, and I don't know why that is. That seem to carry through more in Canada and Europe and Japan than United States. So that's, avoid deceptive acts, okay, but accepting responsibility for your work is an interesting concept that does carry through. So it might be that they've had enough, they've been around longer, maybe they've had more failures and more issues, and they recognize that, to be professional, they need to express that right off the bat, that they're going to commit to that type of thing. So let's figure out how did these sort of engineering ethics develop in Europe? Well, it's actually, ethics in the United States is much more of considered a professional ethics, like business ethics, legal ethics, medical ethics. Engineering ethics is sort of interpreted by people who think about these things as professional ethics, whereas European ethics, and the same within Canada and Japan, is sort of a amalgamation of not only professional ethics, but also like a human and social sciences ethics and philosophy ethics and technology, and recognizing these different things kind of come together. They used to come together to form their ethical creeds and codes of conduct. But the other thing I found was really kind of fascinating is the first real school for engineering, the first school that said, okay, we are a true engineering school, was formed in Moscow. It was a military school formed in 1698. And subsequent to that, in 1774 was the first, 1744 was the first engineering school formed in France. And subsequent to that, there are schools in other European countries like England didn't come for some time later. But we can think about, the engineering school for military engineers in Moscow. It makes sense, and the King's Draftsman in France makes sense because those schools were created for engineering for military purposes or for social engineering construction purposes. So roads, bridges, were owned by the crown. Military engines, walls, engines of war, things like that were more the focus of the military. So of course, then it would make sense that this is sort of how formal engineering schooling started, with either the government being, the crown in France at the time, or the military being in Russia at the time. But in England, they didn't really start formally having engineering until 1838 in King's College in London. And then not until the 1900s did Cambridge and Oxford actually have engineering degrees. So it was a matter of time before these formal universities in Moscow, France, and others came to places like Britain, and obviously then therefore the United States. And that's part of the reason is because engineers used to be a profession that was created through mentorship and apprenticeship. Yes, sir, you maybe take some classes generally, but then you would work for an engineer and be mentored and follow an apprentice program for years and years and years before you actually go out and do real engineering. So it was sort of a afterthought and maybe as colleges and universities grew more themselves, did they start to incorporate engineering classes and then eventually engineering degrees. And that's one thing that's interesting about professions, real professions. Being an engineer, you have to work, if you want to get your PE license, 4 years under professional engineers. There's still some level of, mentorship and apprenticeship that is in our profession, and but lawyers and doctors as well. But I think we still carry that maybe a little bit more than other professions do. Now, to get a license, to be a licensed professional engineer in Great Britain, the engineering associations actually were given the monopoly. The Institute of Civil Engineers, which was created in the late 1700s, is the group that licenses engineers, and in those cases. Conversely, if we look in the United States, we have 50 different licensing agencies for professional engineers. Every state has their own licensing. Canada actually has one, and that's through the Canadian government. So I thought it was kind of fascinating that if you want to be an engineer, professional engineer, recognizes that. In England, you actually have to go through this Institution of Civil Engineers, and then they also do they make sure the college courses are appropriate, they make sure you're trained appropriately, you have the right education, you have the right mentorship, you have the right take tests, just like we would here in the United States. It's similar in that way, but it's a run through that group, and I thought that was sort of interesting. So we have these, there's been engineers, people considered engineers for thousands of years. First one being, Imhotep in Egypt 2,000 to 4,000 years ago. And I've done a presentation on the history of engineering, talking about the engineers of, Rome and Greece and et cetera. Formal engineering schooling didn't happen until 1698 through Moscow. It didn't have engineering societies until the 1700s. It started in Great Britain. And really the first code of conduct was created from those engineering societies in Great Britain. It was called, it was their code of conduct. Subsequent to that, we have in the United States, American Society of Civil Engineers, I believe, created their first code of conduct. But Europe itself was sort of, beyond England, was very late to the party in coming up with codes of honor and codes of conduct. So the next one that's relevant really is the Scandinavian. You think, when I think of engineers in history, I think of engineering, Scandinavian engineers, German engineers, Scottish engineers, I think we think about them as creating great structures and roads and bridges and things. It's interesting that they didn't have a real code of honor, code of conduct in Scandinavia until 1929. And in France, interestingly, not till 1997 did they have one. Maybe they think they didn't need one, I don't know. But even the last one was Germany. They had no formal code of conduct, formal code of ethics until 2001. Like, wow, that was really kind of fascinating when I did that research. That we've had ours through ACEC since I think like 1910, but they didn't get their most recent formal code of conduct in Germany until 2001. Now I've been jumping around talking a lot about the different states or different countries and what they've been doing. Let's go ahead and get into now these sort of engineering disasters. I would like to have done 5, and I'm looking at my time, and I'm actually going through this presentation sort of fast, so I'll slow it down a bit. But I wanted to do Canada, US, China, and Japan, and France. And for brevity, I took out France, but I was going to be talking about the Charles de Gaulle airport failure in France, which just didn't happen that long ago. And you'll find similarities between every one of these disasters, and I'll just share it with you, sort of insight into that. It's basically the arrogance and hubris of one or two folks, and then the interest in doing things on the cheap. Those two things are very common in these engineering disasters that I looked at with these different countries. Now there are, again, you can go through hundreds over history of disasters that could be attributed to engineers, but this came from engineeringclicks.com. And it is this group of 25 engineering disasters. Oops, sorry about that. My presentation went into autoplay. And these are the ones I'm going to be highlighting and talking about today. The Bangkok dam failure in China, 1975. Not the largest disaster in China, but the largest engineering disaster in China. The Quebec Bridge disaster in Canada, 1907. It was, infamously, the bridge failed twice. They built it, tried to build it, it failed, tried to build it again, it failed. And then subsequently it was taken over and finally constructed after, quite a few deaths, sadly enough. About this Boston molasses disaster, and it definitely rang true to me as to how engineers failed and dropped their ethical requirements, and had they been following the rules they should have been in place, they wouldn't have had so many people, such a disaster, and so many people die. All of these, I think, except for Fukushima disaster, I don't know if anyone's died of that, but I'm pretty sure it's still sort of a nuclear waste site under perpetual cleanup. So let's get into the first one, the Boston molasses disaster, January 15th, 1919. So in that time, and there's they actually have pictures, which are fascinating. They had 2 massive tanks of molasses. Now, molasses was very popular at the time. It was one of the things, commonly, we have it around right now, but back then it was the most common sweetener that was used. And they had these 2 massive tanks in Boston full of molasses. And the weather, I think there was either an unusually hot day or the molasses came in and very warm, but when they were putting these tanks, 2.3 million gallons of molasses in these tanks, there was no pressure valve for them. So they started to heat up, create gases in there, and that's one of the reasons it exploded. There were the wave of molasses that exploded out of these tanks was up to 4 feet deep. It killed 21, injured 150 folks. And as you would imagine, in the United States, there has to be lawsuits whenever there's a disaster, and 119 lawsuits that lasted, over 6 years. And obviously, 21 deaths is tragic, but one of the 2 most tragic deaths were children. 2 children were actually at the tanks with their molasses jars. So these tanks were so bad and leaking so badly that kids would stand up and put the jars against them and just catch the molasses that was dripping out of the side of the tank. and those 2 kids died immediately. You know, you can't get away from molasses. You think, you know, it would be bad enough if it was water, but the viscosity of molasses, especially in January, was so thick and so dense that just smothered these people and crushed them and killed them against these other structures. And you could see the devastation it caused. The tanks were known to be faulty. They have problems. But the owners said, well, it wasn't our fault initially, and there was actually an investigation, because initially they didn't. That's why the litigation took 6 years. Initially, they said, well, this is anarchists. And thinking about the time, you know, 1919, there was fear of anarchists in the news, the United States. There were bombings. It was around World War I, and so they blamed it on anarchists. But the class action lawsuit revealed that it was actually failure of the tank, and determined through court auditor that that it was clearly their negligence, and they paid hundreds of thousands of dollars to the families of the deceased. Well, the tank was designed too thin. It was too brittle for that climate. The metal was too brittle. It was never really inspected. Like I said before, there was no release pressure for the gas as the molasses, you know, expanded. There was no place for it to go, and there was actually bulging and groaning, and like I said, leaking from this tank that were not fixed. And so, who's the engineer that, you know, caused this? Who's the engineer that failed? Well, the person who designed the tanks was actually Arthur P. Gell, and he was not an engineer. He was a financial advisor, and he told folks that when there was leaks, that they should just go paint over the leaks. So basically, he wanted to hide the cracks. He built these tanks on the cheap, but there were engineers working for these companies. They actually had a railroad spur. They had other engineers that were around this facility. So there were failures. Obviously, you know, Mr. Gell working outside his capacity. That's one obvious failure. But there were failures of the engineers who were around and should have done something and didn't. And part of it was just cost, just expense. They put together these cheap tanks. They filled them, and there was a robust industry. They're making a ton of money. And so rather than doing anything real to address the problem, they just painted over the cracks. And of course, then they had a tragic accident. So what code of ethics, you know, what did they fall down at? Well, I think it's, you know, sort of obvious. Generally, Arthur P. Gell should not have been practicing engineering. I think it's those engineers who were at the facility should have said something. Should have said, hey, this guy, he's an accountant. He shouldn't be designing these tanks. And therefore, they failed their first requirement to protect the health, safety, and welfare of the public. Now, ACEC was actually in existence at the time. This is an update to their code of ethics. I don't know that they had a code of ethics at that time, 1925. But they actually, no, in fact, they did. In 1910, they had a code of ethics. So clearly, folks, you know, the engineers failed. I don't know if they're members of ASCE, as you can imagine, but they would have failed their ethical requirements. And when, you know, this person was asked to do something, Mr. Gell, he didn't, you know, go to engineers. He didn't, in his own hubris, in his own interest in saving the company money, he basically, you know, practiced engineering without a license. So those engineers that work for the company should have reported him, should have had zero tolerance for this, and should have recognized that he was not capable of designing these, especially when this thing was groaning, cracking, and leaking molasses. Now, the next failure I will get into happened in Canada. Engineers Canada is the premier group that represents professional engineers in Canada. 300,000 members strong. They're actually an arm of the Canadian government. And like I said before, you know, interestingly, in the United States, we have 50 different groups that certify and provide engineering licenses. In Canada, there's just one, Engineers Canada, and they go through, and they're the regulatory arm, and they create the, you know, college courses, and they have peer review applications. They create testing to be professional engineers in Canada. Now they have 10 core purposes that they claim to establish for Engineers Canada. They, like I said, their purpose is to credit programs or undergraduate, create working relationships with between engineers and regulators. I won't read them all to you, but you can see that these are what Engineers Canada says was their purposes for existence. they also have a code of ethics. And they require that right off the bat, just like in the Ohio Administrative Code, that engineers conduct themselves with integrity, that they will be honorable, that they will be ethical. Number one, hold paramount the safety, health, and welfare of the public and protection of the environment to promote health and safety within the workplace. So clearly, again, similar to what we've seen in the other engineers groups, societies across the world, similar to what we have here in the United States, similar to what we require in Ohio. The last two, though, I didn't think were similar, and I brought those to the group's attention. Be aware and ensure, excuse me, 8 and 9. Be aware and ensure that clients' employers are made aware of societal and environmental consequences of actions or projects. That was interesting. So, in other words, I think they want you to, engineers in Canada are supposed to disclose or maybe advocate about or maybe even against a project. I couldn't quite be sure of this. I guess maybe it depends on what side of the ledger you're on. Are you there, for the developer as an engineer? Are you there for the government as an engineer? Are you there for the person protecting the environment as an engineer? What is your role? But if you're there for the developer, and are you supposed to disclose that there are environmental consequences to the project? I guess in Canada you are. So I've obviously not delved into it with much detail, but it makes me curious as to what their obligations are. And then, of course, to treat equitably and promote the equitable and dignified treatment of people in accordance with human rights legislation. So there, again, they're getting into equity and treatment of folks is part of the ethics of an engineer. We do not see that at all in the Ohio Revised Code or Administrative Code. We do see that, though, more trending in codes sections for like the NSPE or ASCE. So in Canada, the disaster I want to talk about was the August 9th, 1907 collapse of the bridge over the St. Lawrence River. It was constructed by a private company, the Quebec Bridge Company. They started working on it in 1887, and it was a cantilever bridge. They thought that would be the cheapest to take this railroad bridge across the St. Lawrence. But unfortunately, in that fateful day, August 29th, 1907, the bridge collapsed. 75 workers died. And then when they took a step back, tried to do some redesign, rebuild it again 9 years later, suffered a second collapse and 17 folks died. The reason it collapsed is because it was actually it was deformed while it was under construction. It was the strains were deforming the members, and the engineer in charge, Mr. Cooper, was the designer, but he refused to have anybody inspect his work, or rather inspect his design. So because there were other engineers that were involved that were helping him work on it, but he was the lead engineer and refused to take any of their comments into consideration. He actually lived in Boston while this was being constructed. So he didn't go to the site to see the deformation of these beams. He didn't go and ever listened even to like the workers. There were many workers on this. They actually had several walkouts from the construction workers saying, "Hey, we see this is dangerous. These loads are deforming these beams." And they said, "Oh no, those are just construction. These beams are constructed inappropriately in the manufacturing process. They'll basically fall in line. Just keep working." And sadly enough, 75 folks died. Interestingly, 13 of them were indigenous Canadian Indians, and they worked on the especially high rises. And that group of folks, I guess, was known when the research I did indicated they were known for working on these sort of high-rise, dangerous areas and buildings and bridges. And so they would actually go to these indigenous populations and try to use them for this work because they apparently were so confident working in these conditions. And but just like everyone else, when they commented and said, "Hey, this bridge seems very unsafe," they were ignored. And so we take a look at their code of ethics. What parts of their code of ethics did they fail in? And here's the ones that I highlighted. Obviously, clearly, they did not hold paramount the safety, health, and welfare of the public. They didn't protect them, even though they were known. I mean, the bridge was deforming. People were saying, "Hey, we need to stop." Mr. Cooper at the time, the engineer Cooper, living in Boston, actually got sick right before the accident. About a month before the accident, he got sick. And so they were sending him wires and letters, and he was not even responding to them because he was so ill. So again, his arrogance, his hubris, his wanting to do things sort of on the cheap without bringing in any other consulting engineers to help him and advise him, even though there were engineers available at the time that could have helped. So because of this accident, because of these failures, this precipitated the ritual of the calling and the order of the engineer. And again, like I said, from these failed bridge members that were in the St. Lawrence River, they pulled out the steel, melted it down, and created the rings that were first handed out to those 200 engineers on May 1st, 1925. So it's interesting, I think, again, that their calling, their rules were grown out of this failure. And I think that's why that's such a solemn vow that they make, recognizing that, hey, 88 folks died, or 87 folks died because of this one man's arrogance. And last one I'll point out is number 19, treat equitably and promote equitable and dignified treatment of people. He had opportunities to listen to the workers, to the people who were crawling all over the structure, and he chose not to. And I don't think he treated them equitably, obviously. This one, in my mind, is like the biggest engineering failure that no one really knows about, because while now it's public, for 25 years, really folks didn't know what was going on. The Bangkok Dam failure in China. So in China in 1975, Chairman Mao was promoting the concept of turning China from a agrarian society to an industrial society. He called it the Great Leap Forward. And part of that was harnessing the power of water and retaining water for construction, for industry, for activities. And so they created a series of dams, 62 dams, along this river chain. And the biggest one was the Bangkok Dam. The Bangkok Dam was supposed to was created to withstand a 1,000-year flood event. But it didn't, obviously. And it caused 220,000 casualties, and 10 million people were actually affected by this. But it really wasn't disclosed because China itself, and then certainly, and now maybe less so, is a very insular society. So they didn't share what was going on with this dam. It was constructed by peasants. It was constructed by Russian engineers who came to China to help. And you can see from this picture, and it's particularly interesting, you look into the sort of the background here, you'll see that very few trees, very little vegetation. One of the reasons this dam failed and the 61 other ones downstream failed is because they basically scarified the land, thinking that they were going to turn this into an industrial area. So they cut down the plants, they stopped their agrarian production, they cut down trees, and they filled this dam with dirt. It was 387 feet high, with a storage capacity of 17.4 billion cubic feet of water. It was designed to hold water that came from a flood. It was not designed to withstand the forces of a typhoon. And that's what happened here. And that's why it failed. There's actually a Chinese hydrologist at the time who commented and said, hey, look, there's nowhere for this water to go except for rushing into this dam at full speed, because there's nothing slowing it down. Again, the land's been scarified. There's no vegetation. And yeah, while it'll withstand, it'll hold back, these 17.4 billion cubic feet of water. If there are pressures that were created by a natural disaster like a typhoon, it will fail, and it did. Again, it was done during the Great Leap Forward. It was an economic and social campaign by the People's Republic of China. It was, again, built by the Chinese government with the help of peasants. They used peasant-made steel. They were carrying the dirt, and they concealed the details of the disaster until 1990s. Here's a nice picture of the flood that happened afterwards. And so the question then becomes, well, what were the ethics of the engineer? Well, the Chinese hydrologist was the only one who did speak up. They brought engineers in from Russia. Those folks, obviously tried, I guess, the best they could, but they failed. They didn't seek help outside from anywhere else. And part of that is the problem of the society at that time. Again, they're very insular. They didn't go outside. They thought they could do it all. Chairman Mao decided that he was going to push forward the social engineering and these projects to the great detriment of 10 million people in China. And people didn't like instantly die. The 220,000 people actually subsequently died because also they didn't ask for help. They didn't seek any assistance from any of the neighboring countries. They hid that it happened, and people died not only of dying from the flood, but also starvation and diseases that you can imagine that came from those floods. To this day, in 2005, actually a report was released by the Chinese government, and they blame it on the typhoon, 100%. Now, there aren't. I tried to find engineering ethics in China, and I couldn't find anything on there that I could share with you. Ethics codes, ethics principles, anything like that. The only thing I could find is that they do claim that when they teach engineering, they teach the ethics of comply with principles of openness, justice, and impartiality. That's what they claim in their National Natural Science Foundation, that you shall do this. But there's no details to that. That's it. Curiously, then, we look at, well, what's coming out of China. Well, in fact, they graduate more engineers and STEM majors than any other country in the world, but they also receive less ethics education. Now, that's something they should work on, and that's something we should be cognizant of, when we talk to these folks from these countries. So China has a long way to go, obviously, in getting up to speed in engineering ethics. It took other countries decades, if not centuries, to get there, and I would suggest they need to probably embrace that, or other disasters can and will happen. But their neighbor, Japan, had a also very terrible disaster, and it was due in large to a event in nature, another typhoon, a tsunami, but it could have been prevented by better engineering. So the Fukushima nuclear disaster, March 11th, 2011. It's a major nuclear disaster. It's a meltdown of this nuclear power plant. Previous to this happening, previous to the meltdown, there was an earthquake, there was a tsunami. But what happened was they designed the structure below sea level. They had a sea wall surrounding it, but it was below sea level. So when the tsunami waves overcapped the seawall, there was very little place for the water to go. And eventually it got into the systems and even the backup systems, and started shutting down the generators, shutting down the backup units, shutting down the batteries, and therefore created, when all those electrical units were lost, the reactors were unable to cool, and it created a nuclear meltdown that's still being cleaned up today. There was a study, there was analysis, there was a detailed review of what happened there, and they recognized that, similar to before, engineers knew or should have known that the seawall, while it was tall enough for regular activity, was not tall enough for tsunami, that they shouldn't be building these things below the sea level, and didn't have the proper drainage to address these things if there was a flood happening. And they blamed it on this interesting regulatory capture, they called it. In Japan at the time, the government was regulating the nuclear industry, but also promoting the nuclear industry. So they had an inherent conflict of interest there. There was little oversight that was necessary to check and balance what was going on there. And the engineers were aware that this could happen. But because of the promotion of the nuclear industry in Japan at the time, didn't promote this. The fact that this failure could happen didn't promote the fact that this accident could happen. And they failed. They failed their engineering requirements, and certainly ethics requirements. Japan has a fairly robust code of professional conduct. I highlighted, and I'll read them, the primary directives for professional conducts for civil engineers. They're supposed to contribute to society. They're supposed to respect both nature and the fabric of civilization and culture. I thought that was interesting, that not only in Japan are they saying to be an ethical engineer, to be a professional engineer, you have to respect nature, but also the fabric of civilization and culture, something that we don't really think about here in the United States as much. ensure the security of society, mitigate disasters, okay. Fulfill the professional responsibilities, good, obviously. Guard their integrity, avoid conflicts of interest. Well, clearly they failed with that. Openly provide information, engage in public dialogue, again, a failure there. Make known the results of their research endeavors, strive for self-improvement, human resource development, and apply with established norms. So interesting that their codes of ethics, codes of professional conduct are similar, but yet not. And we know that they failed, these engineers and the Fukushima power plant failed because obviously they did not respect nature as they needed to. They did not protect against opportunities for mitigation of disasters. It was known that this could happen, but they had this inherent conflict of interest. They did not guard their integrity and avoid these conflict of interest. They should have talked about these issues and made public that these things could happen, and maybe perhaps this tragedy wouldn't have occurred. We have only a few more minutes left, so I'm going to go ahead and jump into real quick Gallup's psychological trends in post-pandemic. So we all know we had the pandemic, it came and went. We're all affected by it, some more than others. But what took a big hit was actually ethics, honesty, integrity of professions. So Gallup put out a survey just last year and showed that every profession took a hit. So people trust professions less post-pandemic. The psychology of that is sort of fascinating, but you can imagine the government being trusted less. You could see, logically, maybe doctors, the medical profession being trusted less because a lot of people were medically impacted, and people blame someone. Police officers affected. Similar time frame, we had the George Floyd incident, so you can see, okay, well, I understand why police officers were affected less, but why teachers, members of Congress always get abused? No one ever trusts them, probably for good reason. But engineers, why did engineers take a hit? Why did college teachers take a hit? Taking a look at this Gallup chart. Well, engineers basically took the same hit as everyone else. I mean, as obviously to a less degree, but just like every profession, every person with a designated profession was lumped in with basically misinformation or promoting misinformation, promoting the ideas that we knew something, and then we reacted this way, and ultimately when it's all over, said and done, maybe we shouldn't have reacted that way. Maybe we didn't need to be shut down as long as we were. College teachers, however, have taken a big hit over the same time frame because of political aspects, because of Republicans actually find college teachers to be 39% of them are ethical professional, while Democrats actually consider 59% to be ethical and professional. And so that's a purely political reaction to the last 3 years and post-pandemic. So the pandemic hit people a lot of ways, and even in their ethics. And here's a quick chart of the are different rules under Ohio Administrative Code, Chapter 4733-3501309. If I had more time, I want to leave a little bit of time, a moment or two, for some questions at the end. If I had some more time, I'd get into how these all sort of interrelate to the different ethics from Europe, from England, from Japan. But we saw that they did talk about integrity. We saw that you wanted to make sure that you're trained and you're certified, and every country finds that relevant. We saw that you need to avoid conflicts of interest. Also, the effect of not avoiding conflicts of interest, and certainly in Japan, improper conduct by engineers and non-engineers with the Boston molasses disaster. So these are relevant, timely, and top of mind, at least for ODOT. I'll transition into this, and then we'll be about wrapped up. Recently, ODOT came up with a new policy regarding conflict of interest laws. I could probably talk more about this with folks if they have more questions after the seminar is over. But they were changing or I guess not changing, but promoting the idea of, hey, they need to be more concerned. We need to be more concerned about these conflicts of interest issues because the federal code requires us to. not only ODOT, but also local public agencies that get money from the state, get money from the feds, also need to be more concerned about this. So my firm represents transportation improvement districts. My firm gets money from ODOT through the feds. Or not my firm, but my clients do. My clients have to sign this now new conflict of interest and ethics disclosure statement because my clients are LPAs. So we reviewed this. I was involved with the ASCE group and Dave Slater's group and others when this was coming down the pike. It was something that I think all folks knew was going on-ish, that there were LPAs that had engineers working for them that may have had other work, didn't maybe understand or feel in the past that it was that much of a priority, but when someone took a hard look at it and recognized that there's a real conflict there, ODOT sort of jumped up and took the helm and I think did the right thing and created a new policy for folks to be aware of and a new conflict of disclosure form that'll help, that'll make it top of mind. So it's out there now, and this is just a quick snippet from it. But if you're an LPA, obviously, and you're doing these federal aid contracts, this is something we're going to have to be more concerned about going future. So we are pretty much towards the end of our presentation. I'll quickly summarize. We learned about that there are many groups, starting at the college level, they're international, that you can get involved with. It's ethical to do so because you're participating in exchanging of information, you're participating in mentoring, you're participating in thinking about these ethical issues from a young age all the way through your career. If you have an interest, you can find a group that you can be involved with socially in the United States or even across the globe. There need to be, concern about some social advocacy. I saw on some of the Facebook posts of some of these college groups that there's some things that they're saying that are borderline, concerning, and they're engineers, and so they need to be concerned about that. They should, watch what they say and what they publish on their social media. But it doesn't matter, right? We know that accidents are going to happen. No amount of education, training, and mentoring is going to prevent every accident from happening, no matter where you are across the world. And we've found that I wish we could have spent more time on it. There's probably a whole seminar I could create on this, that there are many consequences of the pandemic, including a real impact, a real decrease in people's perception of professions. It doesn't help that we have a very, very partisan media. It doesn't help right now that we're going through some unusual times in our republic. And that is not necessarily just a consequence of the pandemic, but post-pandemic, we see these consequences impacting our profession. And engineering ethics, you're here today because you have to be, maybe you wanted to hear me talk about this stuff, maybe you find it interesting, but it is front of mind for our employers. It is front of mind for ODOT. The CFR has been in place for a long time. And ODOT's coming up with some very clean policies on it, and it pays to stay on top of these things and abreast of these trends in this area. So that is our hour plus together today. I hope you've enjoyed the presentation. I see that there are questions, a handful, Mike. So do you want to talk about those? I'd be happy to answer what I can.
Yes, thanks, Tom, so much for gathering and sharing the information for today's presentation. We really appreciate it. We've reached the full hour, so for any attendees that have to move on to their next meeting, that's okay. But we do have some questions and comments, and we'd like to allow a few minutes for Tom to address those as well. So, Tom, the floor is yours.
Thanks. So I'll take a look at this first one. Question: are these societies and professional groups promote ethics on self-help basis, or is there a governing body overseeing these societies? There is not a governing body overseeing the societies. So like the National Society of Professional Engineers or ASCE or even the fraternities and sororities, they are self-regulating. Conversely, if you go to like Engineers Europe or in the United Kingdom, they have fairly uniform groups that oversee the major certifications of engineers. So in the United States, I don't know that there's no uniform body. In fact, there was a unifying body that went defunct a couple of years ago, but in Europe, it's much more cohesive that way. Question 2, what is the origin of ethics in humans? Is in our DNA, or do ethics evolve over time? Oh, well, that's a good question. So I think I've done ethics presentations I've done that presentation on the evolution of engineering ethics. And I think it comes from more nurture than nature. Personally, I don't think people are necessarily disposed to be ethical. I think you have to teach it and breed it and want to do it. How Hammurabi's code of work inspired Aristotle? Well, I'm going to make a note of that because I've obviously studied Aristotle and I've heard of Hammurabi, but I'm going to find out for you what is Hammurabi's code of work, because that sounds kind of fascinating to me. So sorry I can't answer it, but I'm going to look into it. That sounds like it'd be a nice little research topic. Next question from Bruce, a comment on a question I've enjoyed hearing. Okay. Is there a good way for us to review our ethical requirements? I'm not sure what that question is, other than the best place to look at our ethical requirements is chapter 4733 of the Ohio Revised Code. Just lays out the, we have to have 2 hours every 2 years of our 30 hours in ethics. Do ethics of the lower level engineers of the state of the Canadian bridge come under scrutiny if not calling the problem out? Yes. So the person, Mr. Engineer Cooper, who designed that bridge, was actually vilified quite a bit, and his poor decision making resulted in the calling of the engineer. They recognized he failed on multiple fronts. He didn't communicate. He did things on the cheap. He refused to have any other consultants help him design this bridge. So some of the actual terms of the calling of the engineer were developed because of the stories that were written about this guy at the time and his hubris in causing these failures. Engineering ethics as training is a relatively recent addition to our engineering licenses. That's true. To what extent is the engineering ethics currently included in the engineering curriculum preparation or licensing of other countries? Well, that was what I was sharing with you, that in fact in Germany, it just only in 2001 do they actually talk about engineering ethics and their certifications and for engineers. So it's a relatively recent thing, and it's the last 100 years it's been promoted, across the world, but there's still certain countries that are playing catch up to that. So I think what I reflected, what I could find, and I couldn't find much. I don't read Mandarin, obviously I don't read Chinese, but they seem to be also quite behind the curve in getting actual engineering ethics in their college curriculum. But in the United States, it's front and foremost. My understanding now, all these colleges require some type of engineering ethics as part of their degrees. Last question. Don't you see non-engineers in charge of engineering a conflict of interest, both public and private? Yes. Non-engineers in charge of engineering issues could easily be problematic. I'm not sure if it's a conflict of interest, but there are many non-engineers who own engineering companies. The issue has to be, are they making engineering decisions? And if they are, that would be unethical. And the engineers who are employed with them are actually obliged to sort of tell on their bosses, tell on their employers. But the conflict of interest, not necessarily. The conflict of interest is basically trying to work on both sides of an issue. And I see those things in my mind as distinct. So Mike, that's the last question I see. With anything else?
Well, Tom, thanks so much. And thanks everyone for staying several minutes beyond 2 p.m. And at this point, we will conclude today's webinar. So we really want to thank Tom for presenting today. We really appreciate it. And thanks everybody for your participation.
All right. Thanks, Mike.
Thanks.
Take care, everyone.
Bye.